Okay, so the question that I'll be answering is from the Nelson's textbook. It's on page 106, question 69a. So in the question, we are given a launch angle of 41 degrees, a velocity of 27.5 meters per second squared. So based on that, we'll know that this is a projectile motion question. So we need to figure out how long the ball is in the air, for what amount of time the ball is in the air, the distance the ball travels, and the maximum height that the ball reaches. So I quickly redrew that over here. So I drew the football. It's traveling at 27.5 meters per second squared, and it's at 41 degrees. So based on that, we know that this is like a diagonal vector, and to create that, the way you create that, we learned in the last lesson, is you need a horizontal and a vertical vector. So I redrew it as 27.5 meters per second squared as the hypotenuse, and the angle is 41 degrees. So if we're solving for the vertical vector, and we have, so that's like opposite to the angle, so that means we're going to use SOHCAHTOA, and we're going to use sine. So we have sine of theta is equal to opposite over hypotenuse. We're solving for opposite, so we multiply both sides by hypotenuse. So we get 27.5 meters per second multiplied by sine of 41. We use 41 because that's our angle, which will give you the velocity of 18.04 meters per second squared. Oh, sorry, I forgot to write meters per second squared here. Sorry, not meters per second squared. It would just be meters per second because it's velocity, not acceleration. So we figured out the velocity of the vertical vector. Next we're labeled y. Next we're going to figure out the horizontal vector labeled x. So as we see, it's adjacent to the angle. So we're going to use cos. Not focused. So we're going to have cos of theta is equal to adjacent over hypotenuse, so that, and we multiply both sides by hypotenuse to isolate for adjacent. So we have 27.5 meters per second multiplied by cos of 41 degrees, which will give you 20.85 meters per second, and that's the velocity of the horizontal vector. So what we're trying to find, the first thing we're trying to find is the time that the ball was in the air. So, so if we look at it, right, if we're trying to figure out the time that the ball was in the air, we got to use the vertical vector. So if we take, this is where the vertical vector started, and at that point we figured out the velocity. Initial velocity was 18.04 meters per second. So the ball traveled like this, right? So that means at this point it started, the velocity became negative. So at the end, the final velocity, or VF, would be equal to negative 18.04 meters per second. So we can use this formula here to figure out the total time it was in the air. Other formulas can be used as well, but this one's just the simplest. So this is the formula. VF is equal to VI plus acceleration multiplied by change in time. So we can rearrange that to isolate for time. So we have VF minus VI over A is equal to difference in time. So we said VF was negative 18.04, so we sub those numbers in. Negative 18.04 meters per second minus 18.04 meters per second, and divide that by A, which is 9.8 meters per second squared. We know this because that's acceleration due to gravity, so the pulling down on it. So then that will give us a total time of 3.7 seconds. So that means the ball was in the air for a total of 3.7 seconds. I wrote vertical up here just to make it easier to follow. So in this area we use the velocity that we got for the vertical vector, because we're trying to figure out how long it was in the air. So we use the vertical vector. This one, next we were told to figure out how far the ball traveled. So in this one we would use the horizontal vector, which is this one here, because we're just trying to figure out how long it traveled. So, unlike the vertical vector, which went like that, the horizontal vector is a constant, so like right here is a constant like that. So that means the velocity would be the same all the way through. And we figured out the velocity was 20.85 meters per second. So we use this formula here to find the distance. So distance is equal to Vf plus Vi, and difference in time. So we get, what is it? So if we sub that in, we get, like I mentioned, our Vf and our Vi are the same because it's a constant. We get 20.85 meters per second plus 20.85 meters per second, and we multiply this, that's outside the bracket, by both things inside the bracket. So both of those are multiplied by 3.7. Then you divide that by 2. So if you put that in your calculator, you'll get distance is equal to 77.1 meters. So that means the ball traveled a distance of 77.1 meters. So the final thing we were told to find was the maximum height that the ball reached. So if we look back over here, the maximum, I'll just redraw it actually. So it went like that. That's what the ball traveled. So the maximum height that the ball reached should be at the middle. So like that. And that would be the maximum height that it reached. So once again, we'll be using our vertical velocity because we're not trying to figure out how far it traveled. So if we're trying, which we did up there, that's why we use horizontal. For this one, we're trying to figure out what's the maximum height. So we use our vertical velocity value, which was 18.04 meters per second. So that was, so as we covered over here, our initial velocity was 18.04 meters per second. But this time, our VF, or final velocity, will be equal to 0. The reason that is when the ball is traveling like this, at one point the velocity will be 0, and then it will start coming down at a negative velocity. So that's why over here our velocity was negative 18.04, because it started going down at a negative velocity until it hit the ground again. So the point at which the ball reached its maximum height is at the point where Vf is equal to 0. So just keep that in mind. So we use the same formula again. Again, you can use a different formula. This one's the simplest one. So Vf is equal to Vi plus acceleration over time. Once again, we're solving for time. I know the question asked what is the maximum height that the ball reached, so that would be distance. But to figure out the formula for distance, you need to, or to figure out the distance, you need to figure out the time first. So once again, we rearrange the formula, but this time our Vf is 0. So we sub in the value, 0 minus 18.04 meters per second over 9.8 meters per second, and the values cancel out, and we're given 1.8 seconds is equal to delta t, which is difference in time. So next we're next we're doing so the question asked what was the maximum height that the ball reached. So we're figuring out distance. So we use the same formula we used up there. So we got Vf plus Vi over 2 multiplied by change in time. So we said our Vf was 0. And our Vi was 18.04 meters per second. This multiplies into it, and if you divide it by 2, you get 16.5 meters. So that means the maximum height that the ball will have reached is 16.5 meters. So that's this boy right here. That's 16.5 meters. This distance is 77.1 meters, and the total time that it took the ball to go this entire distance was 3.7 seconds. So therefore, the change in the time that the ball was in the air was 3.7 seconds. It traveled 77.1 meters, and it reached a maximum height of 16.5 meters. Now I quickly drew these to see what to show you what it would look like on the graph. So when you're graphing something like this, you need two different graphs because you have a horizontal and vertical vector. So first I drew one for the vertical vector. Like I said, it started at initial velocity of 18.04. It went and it was being decelerated due to gravity, and at that point, which was 1.8 seconds, we figured out the velocity was 0, that also used to figure out a maximum height, and then it became negative 18.04. If we line those up, the distance to time would look something like this. And like we said, the horizontal vector, and by the way, these top graphs are velocity over time, this one's our distance over time. We said that the horizontal vector, their velocity remained constant, which means on a distance to time graph, it would just be a diagonal line.